Hey, good morning and good afternoon, everyone. Welcome to Q-PAC's Quick Unpack Session 4. Today, we're going to be discussing our FS1 control system as well as building integration. Right at the top, we have a few announcements for you. Again, happy to have you. We're excited to be able to host this monthly. Our first announcement is going to be our Q-PAC Summit. Sorry, it's going to be the Impact Summit, October 18th and 19th in St. Augustine at our facility. We're going to have keynote speakers. We're going to be doing demos. We're going to be talking about Q-PAC as a component, as well as the components that consist to make our FS1 system. We're really excited to host that in October, so please mark your calendars. We will be sending out the registration link within the next 2 weeks. June 5th is the date for the RSVPs to begin, and it is limited. So please make sure if you're interested in being down here in October that you let us know quickly because the spots will fill up. We also have some sponsorship packages available. If that is something that interests you and your company, please feel free to reach out to me. I will post my email in the chat. Anybody who wants to reach out, if you're interested in that, we can send you the list of what that consists of. And we'd love to work with you all to make the Impact Summit a big success this fall. So next, I will be bringing up Kurt Thomas. He is a founding engineer of the company, as well as the director of marketing. So he knows a lot of the ins and outs of what we're doing with the FS1 system. And he will be presenting a presentation on the FS1 controls and building integration. So I'll make way and bring in Kurt.
Hey, everybody. How's it going? Thanks for joining us. Super grateful that you're taking time out of your day to join us here and learn about our FS1 system. So yeah, let's dive in. Today, we're going to talk about our controls and the BAS integration. We're going to go over the control panel, the quick connect box wiring. We're going to talk about different ways to modulate the speed, some of the hardwired data that you can get back through digital and analog outputs. We'll talk about the safety circuit and why safety is important. We'll talk about our start-stop feature, the Interlock, Fireman Override, and finally, BACnet Integration.
And quickly to interrupt Kurt, if you do have any questions or anything that you would like answered by Kurt, or we have our product engineer Mark in the chat, please post that in the chat and we will get to you quickly, or we will address it during the presentation.
Yeah, totally. Thanks, Eddie. Yeah, like you said, questions. We love questions. Typically, the most value out of these come from questions asked by you all. So please ask. All right, number one. So I want to start off by talking about our quick connect box. So for those of you that are not already familiar, we mount our patented quick connect box inside of the Airstream on our bulkhead. So what's the benefit of that? So it allows us to provide harnesses from the fan that route to each one of our, from each fan to the quick connect box. So we can predetermine the length of the harnesses. And it also greatly reduces the amount of work that electricians have to do, because instead of wiring each motor back to our control panel, they only actually have to do 2 runs, one for power and one for controls, all the way back to our external control panel. So makes their life super easy. So make sure they're not quoting, the normal fee for installing 18 fans or however many they're doing. We always provide the MCA values, so the minimum circuit ampacity. This is so that you can determine what wire gauge size you need for power, typically based off of the NEC, the National Electric Code. But you can also, sometimes there's some local codes. So we provide these raw values for the electricians. We have the quick connect box itself. We think about every single aspect whenever we design something. And so we limited the size of our quick connect box in 2 ways. The first one is the total power consumption that can come into the quick connect box. And the second one is the number of fans. So after you get beyond 9 fans, the wires start to become a mess. So we limited to 9 fans per quick connect box. And for the amperage limitation, we offer 1 inch, 3/4 inch, and 1/2 inch conduit fittings on our quick connect box. So we don't want to go above 1 inch, 95 amps. Anything above that, you're going to look at 1 1/4, 1.5 size conduit. So once you get to that size, the gauge of wire and the conduit itself is just hard to work with. So we've made the electrician's job really easy on this standpoint as well. They only have to work with smaller gauge wire. So,
quick question already for you, Kurt.
Yeah.
Todd asks, are there any special considerations for a 100% OA once through system if the quick connect box is located within the unit box?
So let's see, for 100% outside air once through, if the quick connect box is located within the unit box. None that I can think of off the top of my head. I don't see any reasons why there would be any special considerations. All right. So connecting the quick connect box. So we talked about power. Let's talk about controls. For the controls, you only need, for premium, an 8-conductor cable, and for basic, you only need a 6-conductor cable. So these are connecting the external control panel, which may be mounted, however far away in a mechanical room. So a lot of times they're mounted right outside of the air handler, but sometimes they're in a different location. And the control side is super easy. Like I said, 8 to 6 conductor wire, anywhere between 16 gauge and 20 gauge, and it does not need to be shielded. It does, however, need to be run in separate conduit than the power wire, but it doesn't need to be shielded since they are being separated into a different conduit. So, all right.
I think we have an update on our question quickly, Kurt, to interrupt you again. Aaron Levy, who's one of our sales managers. So if he says anything in the chat, everyone, you can trust him. He said, I think they mean mounting outside the Airstream on the quick connect box.
Oh, I see. So actually mounting our quick connect box outside of the Airstream. We don't recommend that. So gotcha. Sorry, Todd, I didn't quite understand your question. We used to do it as a special, but we currently don't offer the option to mount our quick connect box on the outside of the Airstream. I think it just makes things a lot more complicated. And what constraints would you typically see? Maybe some space issues where you don't quite have enough room for that quick connect box and all the fans. That's pretty rare. And instead of moving the quick connect box to the outside of the Airstream, I would prefer to potentially look at different fans that can potentially do more capacity. So. All right. Speed control. So I see your question, Todd. Moisture migration through the unit. So yeah, we've designed our quick connect box so that it can have, it does allow airflow to go through it. So it reduces the condensation that can build up inside of it. Yeah, some very specific applications, this may be a problem if there's just a lot of moisture or our fans are mounted really close to a damper pulling in OA. But yeah, we can tackle those. As case by case, if you have a case where you think this might be an issue. So speed control, we have 4 different options whenever for our premium version, whenever it's in auto mode. So 0 to 10 volt signal from the building automation system is probably the most common way to run our fans. I would say 85 to 90% of applications use our 0 to 10 VDC input. The BAS monitors duct static pressure, and it just modulates the signal to our fans from a 0 to 10. So we also have constant CFM. So basically our fans, you can set a CFM set point that you want our fans to run at, and our fans will modulate up and down in order to hit that set point. So this one's not that common, but where I have seen it used is specifically in hospitals for their return arrays. So a lot of times I've seen folks set, so the air changes per hour is pretty critical, right, in a hospital, pretty strict regulations. So the way I've seen them balance it is they'll set our return array to suck out the correct volume of air to meet their air changes per hour, and then they'll set the supply fan array to just maintain static pressure in the building. Constant static pressure. So we can also maintain static pressure. If you want to install a static pressure sensor, 2/3 of the way down the ductwork, and run a and have a pressure transducer that outputs 0 to 10 VDC, then you can connect it to our control panel. And that way you don't even need the building automation system to maintain static. And the last way is, excuse me, the last way is BACnet control. So you don't actually need to do a 0 to 10 or constant CFM or static or anything. If you just want to connect BACnet, you can control and modulate our fan system that way. It's not very common. I don't know. BACnet can get interesting. I've seen several cases in critical applications where they don't always trust their BACnet network to stay up. So if you do have a critical situation, I always recommend using one of the other methods. All right, so we have an HOA switch built into our control panel. With our basic version, all of our control panels come with an HOA, and you feed our control panel as 0 to 10. With our premium, it also comes with an HOA, and you can literally rip out our PLC. You can hit it with a hammer, do whatever you want to do, put it in hand mode, and it will still operate the fans. In off mode, it just turns our system off. It won't throw any alarms or anything. It'll just give the status and say, hey, your HOA switch is turned to the off position, so I'm not going to run. When you're in auto, it will use one of the control modes that you select, one of the 4 that we talked about in the previous slide.
Quick question for you, Kurt.
Yep.
Nick asks, can the pressure set point be controlled using a UI or only BACnet?
So you can set the pressure set point. If you're running in constant static, you can set it at our display. You can also change it via BACnet. Hope that answered your question. All right, next slide, digital and analog outputs. So basically what data, hardwired data can you get from our premium control panel? So the first one, we have 3 digital outputs, a ready state. So basically it's saying, hey, I'm ready to operate. It may already be operating, but it's just the status of our system, right? So if the safety circuit's closed, if the enable disable switch, which is just a switch on the display on our controller, is enabled, the start stop is set to start, and our HO switch is in auto, then RO1 is going to be in a ready state. So RO2 is just saying, hey, my fans are running. So with EC fans specifically, they can modulate down to 10% of run speed. So as soon as our controller sees that at least 1 volt is being sent to the fans, then it will close relay number 2 and give you a signal that say, hey, these fans are running. They're actually spinning. And then relay 3. So if you're not monitoring BACnet, any of our errors via BACnet, you can get the individual errors and see exactly what the status is. But if you don't have BACnet up yet, or if you just want to back up and you don't completely trust your BACnet network, then you can tag into relay 3 and it'll say, hey, either I have errors or I don't. It's purely a binary output. All right. So the safety circuit. So we use, it's a standard safety circuit. You typically will want several sensors in your safety circuit, including a high stat, low stat, to make sure your ductwork doesn't cave in or explode. Sometimes you'll put a free stat on there from your coils. A lot of folks will add a door switch as well, and you wire these in series. Please wire them in series and not parallel. I've seen that mistake several times. And occasionally you'll see some fire and smoke sensors as well. So if any of these trip, it does completely kill power to our fans. So if you have a door switch, right, and you open the door, then the fans are going to be freewheeling until friction just slows them down, but the fans will not be energized. So if there is a live wire, you need to work on a motor, you can do that. I would prefer you to turn the disconnect completely off, but it is possible. All right. So our start stop. This is digital input number 2. Basically, this is just a binary signal from the building automation system saying, hey, I want you to start or I want you to stop. It is used for all control modes when in auto. If you move it to hand mode, say your BAS goes down or your then and you want to put it in hand mode, then it will ignore the start stop and it'll run based on the input. So start stop, if you are in constant airflow or constant static pressure mode, then really the only thing you need to connect from the BAS is the start stop wire. So the BAS can just say, hey, I want you to operate or I don't want you to operate. So it can be as simple as that. The interlock. Okay, so we have an interlock function. Most of the time when this function is used, it is connected to a damper, either the actuator or the actuator's end switch or the damper blade's end switch. So basically, if you want our system to control a damper locally to ensure that it opens up, then we can totally do that. So this is how you would wire it. There's a little wiring diagram here at the bottom. First, you would have to enable the use of interlock because it is disabled by default. So if you want to use an interlock, you just go into the screen and say, hey, enable this feature. You can connect the power source to your damper and run it through our controller through relay 1, as we talked about earlier. And then typically any damper or any actuator is going to have an end switch already on it. So you can just tie into that on the actuator. I always recommend adding an end switch to the actual blade of the damper. I've seen it too many times where a damper or the controls contractor, whoever's installing the actuators, will not secure it to the damper rod properly. And so we'll get a signal where the damper is actually, or the actuator's opened up all the way, but it's sliding on the shaft of the damper. So the damper's not actually open and the blades will get blown off. So I always recommend using an end switch specifically on the blades themselves. This is a pretty good option, in my opinion, for critical applications where, so typically how this is handled is the building automation system monitors the damper, monitors our fan. It'll send a signal to open up the dampers and then a delayed signal, delayed start-stop signal to our fans to operate the fans. So they ensure that the damper is open. But I think it's more robust if you actually use our system locally to control the dampers. That way you can ensure that the damper is open in the event that the BAS goes down. Fireman Override. All right, so this one's interesting and not very commonly used, but when you need it, you need it. So I get this question a lot, like when would you ever need a fireman override? So the answer is typically in large buildings. I think all skyscrapers have this, that in the event of a fire, there's a little cubby that the firemen have access to, and they can override the air handlers with. So if there is a fire on the top floor, say of a 50-story building, you either want to shut the fans off so that it chokes out the fire and you don't supply it with new oxygen, or you want to pump fresh air in so that the occupants actually have time to exit the building without suffocating. So a lot of times you will want to suffocate the fire on the floors, but you want to make sure that the stairwells have fresh air because that's where most of your people are going to be coming in and down out of the building. So there's several different sequences depending on the purpose of your fans that you might want them to do in the event of a fire. So the fireman override, there are preset functions. You can completely shut down our fans if this feature is enabled, or you can run them at a set speed. You can say, hey, in the event that fireman override is enabled, I want my fans to run at 60%. So you can set them up to do that. There's 2 other modes. You can have them just operate normally. You can say, yep, fireman override's been enabled. The BAS still has control, but our system's going to at least give an alarm and say, hey, we are in Fireman Override mode. And then the last control type, it actually changes the control mode. So let's say your building automation system is feeding our fan system a 0 to 10 volt signal. In the event of a Fireman Override, it can change our control type to constant static pressure. So let's say you want our fans to maintain static pressure without the BAS. Our Fireman Override can do that. So the assumption anytime there's a fire is that the BAS is offline. So this mode is built so that the firemen can actually operate our fans and they can do what they need to do in that event that the BAS goes down. So. Now let's talk about BACnet. So this is your typical stack, your protocol stack for a building. You'll have your individual components down in the field. There at the bottom of the slide. That's where we would fall. That's where FS1 would fall. We're a little bit more complicated than your pressure transducer, but we do communicate through MSTP and give you a lot of great data. And then there's the automation side. So all of your devices run back to the automation side. That's where the logic is done. That's where the controls contractor will make all of your set points and all of your sequences. And then the last one's the management side. So that's where most of your HMIs are going to be for the entire building. That's where you can toggle some of your set points. And this is the most common stack. So we offer BACnet MSTP. If you do want to go straight to IP, we have a device that you can add. It's fairly cheap. We'll send you a link to it that you can add and go straight to BACnet IP. But we haven't developed it. We haven't integrated IP into our system yet because honestly, there's just not a lot of demand. Everybody's still using BACnet MSTP for that field side. So these are this is the object list. So these analog inputs, this is where you are monitoring the status of our fan. So fan speed will tell you exactly what our fans are running at and as a percentage of total RPM. Analog input will tell you the exact airflow that the fans are outputting. Will tell you the power consumption in watts, the voltage, the current. I'm not sure if we have local static pressure anymore. I think we might have done away with that one. So maybe somebody, Mark, can correct me if I'm wrong. Analog value, so fan speed input. So this, if you are controlling the speed of the fans via BACnet, then this is where you would input that data. Analog value, airflow set point. So for constant airflow, like I said, you can set it at the screen. Typically, you want to set it and leave it. But if you do need to change it remotely for any reason, you can do that here. Same with the static pressure set point. All right, and these multi-state inputs, these are, again, just monitoring the status of our system. Interlock status, it'll tell you if it's being used at all, and then if it's enabled or disabled. The multi-state input number 1 tells you the status of the Fireman Override. Is it actually enabled? Is it engaged or disengaged? Multi-state input 2, it's just your system status. So there are 10 different statuses, and we'll tell you exactly what's up with the system. Hopefully it's always in that okay mode, but if it is, and like if you have an interlock that's not being made, it'll tell you here. If you have an alarm, it'll tell you have an alarm. If your safety circuit's not made, it'll say, hey, your safety circuit is not made. It's really convenient for troubleshooting when you first start up. The status is also shown on our display. And then the integrator statuses. So an integrator to us is an entire, it's the quick connect box and any fans downstream of that quick connect box. So we will tell you if you have an issue with that integrator, and then we also have individual fan statuses, which we'll get to. Control type. So this will tell you, hey, what control type are you in? Are you in 0 to 10, constant CFM, constant static, or BACnet? And you can toggle that here if you want. Typically, that's just set at the display and then left alone. And and D, these binary values. So these are the digital values that we went over. RO1 is your system. Oh no, sorry. This is your system enabled or disabled, and you can toggle that. That's just basically a start stop, except one for BACnet. Interlock toggle. We talked about interlock, and then integrator area fan 1. So from there, you can get the individual status of all of your fans. It's going to say, hey, you have an error, or no, you don't have an error, and you're good to go. And really, that's it. So that's the control side of FS1. I hope you all learned something. And are there any questions?
While people are writing their questions in the chat, I'll do a couple quick announcements while we're waiting for those. So a reminder, our impact sub.
All right. I'm not sure. Looks like we may have lost Eddie. So what he was going to talk about is our Impact Summit. So October 18th and 19th, 2023. So we hope to have you there. We talked about it earlier, but yeah, this is going to be a great time. We're going to go over everything Q-PAC. We're going to have some speakers there talking about all the technical aspects of fans and the digitalization of buildings and some other great things. So I would love to see you guys there. We do have limited space, so get your RSVPs in early. And we're gonna have another event, another live event. This next one's we're definitely gonna talk about acoustics and maybe another topic depending on how much time we have. But Mo's gonna go over acoustics and dive into those details, and we hope to see you all there. All right. All right. Thanks, everybody. Thanks, Robert.